back, and as we continue our study of using the derivative in order to find out the characteristics of a function in order to graph that function. And we've been doing it analytically in the last couple of sections, but today we're going to look at how we can use our calculator also to aid us to get these graphs. So the title of this thing up here is, it says, Graphing the Function Using Your Calculator, Finding Extrema, right, max and min, and inflection points using your graphing calculator, and always, and your brain, and your knowledge. Maybe I should say of derivative tests. Okay, your brain. Here, I start off with an easy problem here. Here's the function I'm interested in. In this particular one, you really wouldn't need a graphing calculator to help you here. We could do this analytically, and if we did this, we'd say, let's see, y primed. Let's find our first derivative. We'd say that's 12x squared plus 42x plus 36 minus 0. Okay, is there anything I can pull out of there? Looks like I can pull out a 6, I guess. I can make this 6, and I get a 2x. I'll factor something. 2x plus 21. Oh, no, sorry, plus 7. Plus 7x plus 6. Can I factor that? Let's see. Can I find the zeros of that thing? Let's put a 2x here. Oh, 2. That's a 2. 2x and x. And let's see. Plus 3. Let's see if I get lucky here. Plus 3. Plus 2. Does that work? Looks like it does. I get 3x, 7x. That does it. That does it. So I see I get my zeros are where? My zeros I got at an x equal minus 1.5 and at an x equal to minus 2. Okay. Anyway, let's look at the second derivative then. We're doing this again. Let's start up here again. I'm going to get 24x plus 42. I will take out a 6 on that again. Let's see, take out a 6 and I'll get 4x plus 7. So it looks like x at minus 7/4 is an interesting place. That looks like that should be that should be an inflection point. It changes signs. And here up here we could see these are going to be critical points. These will be critical points. Okay, so we do a little analysis. We could solve this problem. Let's look at what we do on our calculator. That's what this section's about. Now, first thing we do, here's a little graphic of your TI-84. First thing is put the function in. Now, how do you put in the second part? How do you put in the derivative? How do you graph the derivative in y2? And I gave you a handout talking about how to do that. I will talk you through it right now, and if you know how to do it, just fast forward this. But in y2, I go math. I'm at the y2 screen. I go math 8. Math 8 gives the derivative, and then I got to give math 8 gives me that. How do I put in y1? I click the vars button, cursor over to y vars, click on 1 for functions, pick y1. That's how I get y1. It's all written down in the handout. I'm going to do comma x, comma x. How do I know that? I looked up this function in a manual. Okay? So now you see when I graph y2, I can get a derivative. And that's what I'm graphing right here. That's what this graph is. This is f prime of x. And if you look at this, this is incorrect here. This should be f prime of minus 2. F prime of minus 2 is a 0. And what about that point there? Well, from my analysis before here, right, look at that. X at minus 1.2 should be a 1.5, sorry, so f prime at minus 1.5 would equal 0. But if you didn't know the analysis, you could look at that and you could see what? Well, what kind of point should this be? Here on the original function, we see the derivative is going from what? Positive. Let me change signs here, because you need to be able to look at a derivative and talk about what the function is. Very important concept. Let's change it to green. You see here the derivative is positive, and then it goes negative. Okay, so if it's going positive and then goes negative, this must be a max. That's a max on what? On f of x. Here, notice what happens. It goes negative to positive, so it's going, the slope's going negative and then it's going positive. So here we got a min. This must be a min. Okay, and you could also see by the second derivative. What's this curve right here? We're getting kind of busy right now. This straight line curve right here is what? That is the, and I'll pull that up here, that is the second derivative. Okay, and you can see the second derivative is positive here. It's positive here. Another second derivative would tell us that's a min also. As would its negative here, telling us that's a max. Okay. So here we've got to look at the first derivative and the second derivative. We could probably get ourselves a little sketch of a curve here. Let's do it and see. I think, and then if I, with just that knowledge, first of all, I see this is x cubed, right? It's 4x cubed plus 21x squared plus 36x, oh, minus 20, my calibration needs to be fixed here. But since it's an x cubed, you know, as x goes to infinity, it's going to go off to infinity, right? Looking at some asymptotes, as x goes to infinity, it's going to go to positive infinity. X goes to negative infinity over here, it's going to go to negative infinity. What else do we know? We know at 0, at x equal to 0, it's at minus 20. So we know 0 minus 20. And then what do we know? Well, we know we got a minimum at minus 1.5. So over here, we got a minimum. So at minus 1.5, and I'll just say, I don't know what I need to put the function in here. I got a minimum, and then it's somewhere here. It's going to go up like that. It's going to get a minimum, and then it's going to what? At minus 2, this is minus 2. Well, not to scale here, but at minus 2, I've got a maximum. So this point here must be minus 2. And then the function at minus 2. This is what the function at minus 1.5. Okay, so I've got a basic graph here. Now I don't know, right? This whole curve could be shifted up or down. I don't know. This max right here might be above 0. I'd have to plug that in to see that. But I do know what? I know my min is here. My max is there. Maybe I should do this in a little bit better colors. Okay, here's my min. Here's my max. Do I have an inflection point? Oh, I got an inflection point right here, right? The inflection point is going to be somewhere right in the middle. You know, there's going to be an IP right here, inflection point. It's going to be an inflection point. This is a max. This is a min. Okay, so we've gone 10 minutes here, and I've really picked an easy problem to start with, showing you, remember, make sure you can enter this in your calculator, and you can use the calculator to show you what you could have done analytically. You didn't need a calculator for this problem. Let's look at the next problem. I think you'd be happy to have a calculator. I have a few more things to finish here before the next problem. You can see here's the graph we came up with. Right? Here's the graph we came up with over here in red. Now notice if I graph the thing, okay? So this is kind of interesting. Say I would have just graphed. You're saying, well, if I can use a calculator, why don't I just graph the function and just plot it? Well, if you see here, right here, if you just graph it, and you wouldn't even notice, see? If you're not looking, as I say here, if you're not going to look at the derivatives, first or second, we could miss local maxes and minimums. And actually in another book I used in the past, they called this chapter using the first and second derivative to reveal hidden behavior in the function. And you can see if you didn't zoom in enough, you would never have seen. You never would have seen that this thing actually comes down and up, okay? You won't see it because they're not zoomed in enough. So again, using the analysis gave us a better picture. And as I said, the last problem was easy. You didn't need to use your calculator. But there's going to be problems which are difficult to find. Difficult to find things. So we're going to look at this problem right here. Here's what we call a rational function. And the derivatives are a little more nasty. So let's deal with that next.